Hey, what's up? Welcome. Anti-aging here. So it's anti-aging's researcher here. Well, we do anti-aging for ourselves, I guess, and or humanity here, or families, or relatives, and especially for ourselves, I guess. We want to extend this war as long as possible. Anti-aging is just one form of the maximizing one's personal interest here, to be a surviving, to be a prospering and thriving here in this world we live in here. And when it comes to here really taking practical actions here, anti-aging here, the disarm wheel is the most key here. I don't know that 2020 is gonna be the greatest year so far up to humans to make the really real progress of the anti-aging here. First, it is to understand here the precise how the biology of the life really function here. It is fundamentally to see in a physical cause and effect way here what is aging is really in a cellular level here. The human organism is incredibly complex machines here. As a human we only see some element here, but when it comes to microscopy here, like SEM here, I'm putting in human body here like 80 kilogram person in an SEM, they will see that the person have like a 25 exponent of atoms on his body here, and that quality of the enormous of the magnitude of the atoms, 25 magnitude of atoms of the person here, is really going to high different level here, be a very complex machine here to function here. So no people are alike here in absolute sense of the. And the genetics was kind of interesting thing here to see how the reproduction here, how the cells and how the thing here. It was interesting experiment with telomerase, I guess, and you see that could be just using telomerase enzyme here to extending of this so-called of somatic cells indefinitely here. Is it possible to just adding some enzyme telomerase here, and could be able to hear, and it basically what research was like, it didn't work out here. And I want to repeat this experiment over different kind of ways here. When it comes to somatic cells here, was different lines changing different ways of the function here, and then not just doing it for one cell, but doing it for billions and millions, like, and because most of the human cells are somatic cells indeed here. Then there are the stem cells and the germ cells here, which, and see the difference about it, what gives them the germ and stem cells, which they do not possess, like somatic cells, this senescence here, and are some level immortal in the terms of aging here. And what was about this here case, you know, what I see here case is like we human bodies, all the people in the world who's age and die off here case, and nobody's managed to ever replace all these cells here case and the bodies here. Here's a brain here, we have like 1 kilogram of the fucking brain here, and how is the fuck are we gonna like, it is somatic cells, these neutral cells, whatever, are still senescence cells case in here. And it's not a surprise that some people here, guys, in aging here, will destroy the nerve cells here, and the progress or a process of aging here, affecting of these neurocells, they will all getting destroyed, become a senescence by over the time here. How to stop those cells and able to repeat? What about the loss of memories? What about the repetition? So it's kind of interesting to go to neurobiology here and the study of the neuroaging here, because you know, the neuroaging is kind of like concept where a person brain cells and how they function here to able to keep the base of the loose of those cells here. So some cells will constantly die here, neurocells here, and there's a new cells are generated. But every day, in a given lifespan here, guys, and eventually there's more damage over accumulated here. the, the world and life and universe did not design humans to live indefinitely here. And give this limited lifespans here, guys. And every individuals are constantly dying the moment they born here. And in order to stop this process here, are we guys doing any progress ever here? We are lazy here. That's all. We don't care about here. Some people do a lot of work here, and some people do nothing, next to nothing here. Most people in work really do very little here. And the kind of thing is that when it comes to really to make a progress, we can take all these computers and artificial intelligence, etc., and try to make a computer scientist here. And there's a lot of different fields is run, not just some laboratory work here, or the medical models here, or doing just the in vitro study laboratory here to see how this somatic cells function and how to really keep them alive here, really here. Instead of trying to keep some mouse alive here indefinitely, it's trying to keep some somatic human cells alive here. There's a different cell lines here. Some cancer cell line. Ooh, cancer. Kind of thing is like the creating different kind of new cells what are not existing naturally here. And I'm also creating new ideas about the cells here. Here are my ideas of cells of the human body that I haven't not naturally any living organs possess here. One of them is a specific cell which is able to specifically able to be programmed by humans, even computers, to specific biological here. It is immunocell here, a new kind of immunocell which is able to detecting any kind of pathogen and have given the prior programming by humans here. Oh, it's able therefore to able to scanning the human bodies using a different kind of a human created nano small microscale of the different kind of processes here, the different viruses like HIV virus here. It can be also used about the repairing of some damage here. There's a different kind of cells and different function here. And one of the cells this does exist human body is able to and indefinitely constantly to keep the human physiology like a blood here. There are different cells like a cell which is able to just eat, example, arteriosclerosis here, to take in excessively LDL and taking the plaque from here. It's interesting, like nobody seems to be able to discover here any medication which can be just taken in body here and will take it off here, the arteriosclerosis here, to remove the plaque from a human vascular system here. Like, what about the emulsification here? What about injecting cholic acid here, guys, in order to the guy Sibella in a human blood stream here, like in intravascular injection here? What will happen? Is it able to emulsify some plaque here? Or does it take some special repair cell here? And pretty about this repair cell here is it could be able to destroy the plaque from arteriosclerosis, so which seems to be a huge problem here.